All right. So next quiz. I don't know which number is which, but whatever. We'll mark it down in a moment when we finish going over it, okay? Let me look at this. This is deci, kilo, centi, nano, and milli. So what you want to ask yourself is, you want to be able to understand that this is, for instance, a tenth. A tenth. This is 1,000 in a kilo, like 1,000 kilograms in a kilogram, 1,000 grams in a kilogram, 1,000 meters in a kilometer. This is a hundredth, so 100 centimeters, etc., right, in a meter. So what you have to ask yourself is, how many in a whole? Well, there's 100, right? We know that that's 100 meters, okay? So that one's already taken care of. But this is going to be, how many centis in a whole? How many nanos in a whole? How many millis in a whole? Correct? Yes? And here, that's kilo. That's the opposite. In other words, what you always say is, wait, I get it. There's 1,000 meters in a kilometer. Clear? The word kilo means 1,000. The word centi means tenth. I'm sorry, the word deci means tenth. The word centi means 100th. Milli means 1,000th. Clear? See how to work that? And remember, you always work from the larger unit and you ask yourself the question. And I'll explain what that means in a moment. Let's do the first one. We'll use this area down here as my scrap paper. Is that okay? Yes, Edward. Deci is tenth. Thank you. Nice catch. Well done. Okay? Yes? So we're going to use this as our scrap paper. I want to go from 157 centiseconds to a second. So I say 157 centiseconds. I want to divide what I want to get rid of and multiply what I want to add. So this is centiseconds. This is seconds. You always use the larger one, gets a 1. 10 squared, right? There's 10 squared centis in a whole, correct? So this is going to be 157 times 10 to the negative 2. You bring that up. In other words, remember this. Am I on the camera over here?
Barely. Barely, only your hand. Only your hand.
Hey, right here, watch. 1 over a to the n equals a to the negative n. So I'm bringing this up to the top. It's like that. And then this cancels, and I'm left with seconds. So 157 times 10 to the negative 2 is the answer. Are you with me?
Yeah.
Okay. I'm going to erase this. Is that okay?
Yeah.
Okay.
But sir, shouldn't there be only one significant value to the left of the decimal point?
So
Well, that's a good question. The question is this: shouldn't there be only one significant figure to the left of the decimal point? And the answer is this: that unless I say write scientific notation, don't worry about it. See, on the last quiz, I said write scientific notation. I didn't say that here. So if you want to put it correctly in scientific notation, that's okay. So the answer to the first one is 1.57 times 10 to the 0, or what? 157 times 10 to the negative 2. Either way, that's fine. Unless I said, put it in scientific notation. Clear? You ought to be able to work with both. Yes? This is base 10 notation. This is scientific notation. Scientific notation is a particular type of base 10 notation whereby there's only one significant figure to the left of the decimal. Clear? You get it? With me? Okay. Next. So I want to say 42.7 liters. Now remember, you started with three significant figures, you have to end with three significant figures. I don't care, unless I say so. But the point is that when you're doing a conversion, you maintain the number of significant figures. If I say to you, write the answer with the correct number of significant figures, then you would have to. Clear? But unless I say that, don't worry about it. I'll be specific on the question. Yes? Yes or no?
Yes.
Okay. So this one is going to be 42.7 liters times liters to milliliters. .7 milliliters. 42.7 times 10 to the third milliliters. Are you all right with that? Now, if you said, what did we say this was? 1.57 times 10 to the 0, which equals 157 times 10 to the negative 2. Is that what we said?
Yeah.
Okay, and that's seconds. This one is going to be 42.7 times 10 to the third milliliters, which is the same as 127 times 10 to the negative, times 10 to the positive 4 milliliters. Are you all right with that? Yes or no? Okay. The next one, nanometers to millimeters. Okay. Nanometers to milliliters. Okay, so 261 right? Now, what's larger, millimeter or nanometer? Milliliter. So in 1 milliliter, how would you do this? I know that there are, in a whole, I have a nanometer is 10 to the negative 9, correct? And a millimeter is 10 to the negative third. So if I have 1 millimeter, how many nanometers? 10 to the what? Positive 6. In other words, I want to know how many nanometers there are in the larger unit. Clear? That's 10 to the 6th. So the answer would be
261 times 10 to the negative 6.
right? So it would be 261 times 10 to the negative 6, or 2.61 times 10 to the negative 4 millimeters. Is that right? You with me? Okay. Now what? This one? Okay, can I erase these? Okay, so it'll be 0.065, just 0.065, right? Kilometers times kilometers, decimeters. 1 kilometer, let's see. Kilometer is 10 to the third meters, and then a decimeter is a tenth of a meter, right? So what would I say? How many decimeters are there in a kilometer? It would be 10 to the third, 10 to the fourth. Remember, it's a to the n times a to the m equals a to the n plus m, right? So the answer would be what?
0.065.
Would be 0.065 times 10 to the fourth decimeters, which equals 6.5 times 10 to the what?
Second.
Second. Decimeters. Either way. How many people put it like this? Nobody? You all put it like this? How many people put it like this? Raise your hand. Well, do you see a problem with this? David, you're not raising your hand for either one.
Well, that's because I just wrote it out to.
Oh, all right,
6.
okay. All right, I understand. So you wrote it out in standard form.
Yeah, it wasn't that big.
Excellent, that's okay. Okay, can I erase this now? All right. All right. Did we do this one? Okay. So let's do the next one. 642 centigrams, kilograms. So 10 to the third grams in a kilogram, and 10 to the second centigrams in a gram, so 10 to the fifth. So it'll be 642 times 10 to the negative fifth, or 6.42 times 10 to the what?
Negative.
Negative
Third.
third, and it's kilograms, right?
That's what we did.
Yes? Yes or no? Okay. And the last one, erase this. The last one is 8.25 times 10 to the 2 centigrams, nanograms, 1 centigram. How many nanograms in a centigram? There's 10 to the second centimeters in a meter, 10 to the ninth nanometers in a meter. So how many nanometers in a centigram? Did I say that right?
No.
10 to the second centigrams in a gram, 10 to the ninth nanograms in a gram. So how many nanograms in a centigram? 10 to the seventh, right? So the answer is what? 8.25 times 10 to the ninth nanograms, right?
Yep.
Okay? Yes? We'll say, well, we'll do the scoring afterwards, but you okay? Now, let's make a rule. Because people have been putting it in different ways from now on after this. Yes? Yes? You must always put it in proper scientific notation. Clear? I don't want you using a standard notation. I don't want you using, just have some uniformity. Clear? So we'll put it all in scientific notation. Is that clear? Always. Yes? We're off.